Assalamualaikum. So I will show how to solve the question number 24. The graph is given here, which is the curve line function is y equal to x squared, while the straight line is given y equal to 4. As you can see here, this is a cross section parallel to y-axis. So they did not give the boundaries. So let's look at the question A. The question A asks to find the coordinate of A. So here we be given two function. So y equal to x squared and y equal to 4. As you can see here, you just can substitute the 4 into the function y equal to x squared to find the x. So this means 4 equal to x squared, and then simplify, which is square root of 4 equal to x, and the final answer is 2 equal to x, which is the coordinate of A. So the x equal to 2 and y equal to 4. Okay, next. Okay, move to the question B, which is determine the area of the region. So the question asks for find the shaded area. So how to find the shaded area is evaluate the shaded area in the region. So the function given here, y equal to x squared and y equal to 4. So general formula is area equal to integrate from A to B for fx subtract gx. How to determine which the function will represent for fx and gx. So fx represent for the function on the top of the region, while gx represent the function on the bottom of the region. We just substitute the function into the formula. We integrate from 0 to 2 fx subtract gx. Fx will present as a 4 and gx will present for the x square, because x square is the function on the bottom. And then dx, make sure the integral in term of x, because this is a cross section parallel to the y-axis. Okay, after that, after we substitute the function into the formula, we need to simplify first, and then we move to the to integrate the function from 0 to 2. 4 minus x squared, it will be 4x subtract x squared over 3. And next, we must substitute the upper boundaries and the lower boundaries into the x, which is the upper is 2 and the lower is 0. We substitute the upper boundaries first. 4 multiplied by 2 subtract 2 squared over 3. This is the upper boundaries. And then we subtract with the lower boundaries. 4 multiplied by 0 subtract 0 squared over 3, which is the answer will be 0. Therefore, the area equal to 16 over 3 unit square. So this is our shaded area answer.
Hi, today I want to show you how I solve my question. First, I use formula fy minus k minus gy minus k, because I use y because it is in y-axis. And then we do outer layer and inner layer. Outer layer in the outside and inner layer in the inside. So you can see in the diagram which is outer layer and inner layer. Okay, and then I solve the sign operator first, and then I expand, so we can get y plus 4 square root y plus 4 minus 4 dy, and then I calculate 4 minus 4 is 0, right? So then y plus 4 square root y dy, and then I change 4 square root y into 4y 1 over 2, so we can calculate later. After that, I integrate first, so we can get y square over 2 plus 4y 3 over 2 over 3 over 2, and then I simplify first, from 4y 3 over 2 over 3 over 2 to 8y 3 over 2 over 3, and then I substitute upper bound first and lower bound. So you can see on the left side is upper bound and the right side is lower bound, and the final answer is 88 over 3 pi.
Assalamualaikum and hi, my name is Adriana binti Muhammad Azizi from class M3CS 1102A. So today I will be sharing with you my presentation about applications of integration. So let's get into it. So the question goes, figure 1 shows the region R enclosed by the curve y equals to x square, the line y equals to 4 and y-axis. This is a question from March 2015. The question is, set up the integral to find the volume of the solid obtained by revolving about the line y equals to -1 using the shell method. In the next video, I will show you how to solve this question. So as you can see here, the axis of the revolution is at -1. So we need to apply method 1 in order to find the volume. So the formula for the volume is volume equals to 2 pi integral c to d y minus k multiplied by fy minus gy dy. So the k here is representing the axis of revolution, fy is the equation of the curve, and gy is equation of the straight line. So let's insert the value inside the formula. Okay, so 2 pi integral 0 to 4 y minus with -1. Since the equation for the curve is in the terms of x, we need to change it into the terms of y since it's dy. So y equals to x square, we move the square here, we will get square root y. So we insert square root y here. So for the gy, y is equal to 4, then automatically x is equal to 0, so we insert 0 here. And if we solve it, we will get this 2 pi 0 to 4 y plus 1 multiplied by y to the power of 1 over 2. So we multiply it 1 by 1. So the result is y 3 over 2 plus y 1 over 2. Then we will integrate it. It will become y 5 over 2 over 5 over 2 plus y 3 over 2 over 3 over 2 with the integral from 0 to 4. And then we put the, since it's 3 tiers, we need to solve it into 2 tiers, so it will become 2y 5 over 2 over 5 plus 2y 3 over 2 over 3. And then we will substitute the value here inside the equation. We will get the answer here 544 over 15 pi unit cube. So that is how we evaluate the volume.
My name is Iman Zulaika binti Mokhtar. So let's try another question. Figure 1 shows the curves y equal to x squared minus 4x plus 3 and y equal to negative x squared plus 2x plus 3 intersects at point A and B. So this is the point A and this is the point B. The question is, find the coordinates of A and B and find the area of the shaded region R. So this is the shaded region R. We can say that the graph is cross-section parallel to y-axis. Why? Because we have y top and y bottom. So the equation of y top is y equal to negative x squared plus 2x plus 3. And the equation for the y bottom of the region R is y equal to x squared minus 4x plus 3. So how to solve the question? So let's take a look. Okay, first, find the coordinates of A and B. It have 2 marks. So the equation from the graph, we can label it with 1 and 2. So to find the coordinates of A and B, we use simultaneous equation by substitute equation 1 into equation 2. So this is equation 1 and this is equation 2. So we carry the equation 1 to the right side. So when we carry to the right side, the operation must change. Negative x squared, we got positive x squared. Positive 2x, we got negative 2x. Positive 3, we got negative 3. So the equation 2 are remain same. The operation are not changed. So we have 0 to left side. And then we solve. And when we solve x squared plus x squared, we got 2x squared. Negative 4x minus 2x, we got negative 6x, while 3 minus 3 is 0. You can use calculator, so you will get x equal to 0 and x equal to 3. Then from equation 1, we substitute 0 into equation 1. We get 0 from here, then from 1, when x equal to 0, we got y equal to 3. Therefore, the coordinate for A is 0, 3. And then x equal to 3, we substitute 3 into equation 1. So when x equal to 3, we got y equal to 0. Therefore, the coordinate of P is 3, 0. So from here, we can get the coordinate of x of point A and point B. So point A, x is 0, and B, x equal to 3. Okay. Determine the area of the shaded region. It also have 2 marks. So area, like I'm saying here, the graph is the cross section to the y-axis because it have y top and y bottom. So this is the formula to find the area of the cross section parallel to y-axis. Area equal to integrate A to B for y top minus y bottom dx. So let's take a look closer. So in the graph, the boundaries fall on the x-axis. So we already know the x for the point A and the x for the point B. So x equal to 0 and x equal to 3. So the boundaries is from 0 to 3. 0 to 3. So boundaries 0 to 3. For y top. How we get the y top? We get from the graph, the shaded region, the top of the shaded region. The equation is y equal to negative x squared plus 2x plus 3. So we put the equation to the y top section here. And don't forget the minus. It's minus y bottom. How we get the y bottom? We get it from the graph also, the bottom of the shaded region R. So the equation is x squared minus 4x plus 3. So we put it in on y bottom section. And don't forget the dx. Okay. Make sure your integrand will be in term of x. So if we in term of y, you must to change it into in term of x. So in this case, we already got all the x. It's already in term of x. It doesn't have y in the equation. Right? So the next step is open the bracket. So the y top remain the same. The y bottom, because have negative in front of the y bottom equation, so negative x squared will be negative x squared. Negative 4x will got positive 4x. Negative positive 3 we got negative 3. Dx, don't forget the dx. So the next step, simplify if can. So in this case, we can simplify. So negative x squared minus x squared, we got negative 2x, positive 2x, plus 4x, we got positive 6x. While the 3 minus 3, we got 0. I'm sorry, we got 0. So don't forget the dx again. So the next step is to integrate. So negative 2x squared, when we integrate it, we got negative 2x squared over 3. How we got 3? 2 plus 1 is a 3. The power of x, 2 plus 1 is a 3. So the 3 that we got from the power of x will be copied to the denominator. So negative 2x squared over 3. Also the same as the 6x, we plus the power. So 1 plus 2, 1 plus 1 is 2. So 6x squared minus over 2. So it is a plus operation here. So the boundaries, this is the upper bound and this is the lower bound. So the next is we substitute the 3 into the x, into the equation that we got from the integrate. So 3, substitute 3 into the x and substitute 0 into the x. So that's why we got it here. This is for substitution of 3 and this is substitution of 0. So it's minus. Okay, it's minus because the formula minus here. So it's minus. Alright, and we can you can solve it, use calculator. So when we substitute 3 into the x, we got 9. And when we substitute 0 into the x, we got 0. So 9 minus 0 is 9 unit per square. 9 units square. Alright. Therefore, area of the shaded region R is 9 units squared. So we already solved the equation. 1 and 2, and we got the 4 marks for this question. So thank you.
So question 27. Figure 2 shows the region are bounded by the curve y equal to x squared 2 and y squared 2 equal to 8x. Find the volume of the solid generated by revolving R about x equal to 0 using T-Washer's method. So this is the graph from the question. And if we visualize the cross-section perpendicular to y-axis, it has been like this. And this question about cross-section perpendicular to y-axis, so we must find the x equation. So we just change the y square equation to the x equation, and it's become x equal to y power of 1 over 2 and x equal to y over y power of 2 per 8. So this is the equation that we have to use on this question. Outer layer minus inner layer. So we just substitute the DC into the for 0 and substitute the Fy. We take from the equation from the graph y power of 1 over 2, and then just substitute all of that, and then you just 1 over 2 times 1 over 2 times 2, and then you got y minus y power of 4 per 64 dy, and then you integrate the formula and it have become like this: y square over 2 minus y power of 5 per 64 times 5, and then you just substitute the y into 4 and minus 0, so you can get the answer of 24 per 5 pi unit per 3. Then that's all.
Assalamualaikum everyone. My name is Nurhairis Izzati binti Hairozi. So today I will show you how to solve question 27 to Roman. Before we start, let's read together question. Figure 2 shows the region R bounded by the curve y equals to x squared and y squared equals to 8x. Find the volume of the solid generated by revolving R about y equal to 0 using Shell's method. So, from the figure, we can know that the outer layer is y squared into y squared equal to 8x. And the inner layers is y equal to x squared. Okay, it parallel to x-axis. So first of all, we need to know what formula we want to use. We will use this formula. Before we substitute all the information into the formula, we should find the fx and gx. So the outer layer is y squared into y squared equal to 8x. Okay, then we just simplify like this, and the inner layer is y into x squared. So it will be like this. Then we need to know from what we will integrate. So we will integrate from 0 into 4. Then just substitute all the information into the formula. Okay, this is 0 into the 4 is the boundaries, and k equal to 0. Fx is y square root of y, and this is the gx, y squared over 8. Then just simplify. y, subtracted 0 will turn to y, and square root of y we will transform into y power of 1 over 2. Then, you need to multiply y into this part. It will turn to this. Okay? Then, let's differentiate these parts. So normal dy, it will turn to this. Okay? It should be for 0, sorry. And when we'll differentiate it, normal dy. This is third tiers. Okay? This is third tiers, so we need to transform it into 2 tiers. Okay? Then next, we need to substitute 4 into the equations, and it will be like this. Okay? Y will turn to 4, and we need to subtract it with 0. Substitute into the equation. So it will be like this. Okay? Y will turn to 0. Then just solve it. Okay? Solve in the bracket first. Then you multiply 2 into this part. Bear in mind, no need to multiply the 5. Just leave it. Then you get the answer 48 over 5 by unit. Or you also can write it into the decimal places, and the answer will be 9.6 by unit of 3. So I hope you understand how to solve the question. This is the conclusion. This is the formula of area. This is the formula shell method. It can be 2 situations. First one is cross-section perpendicular to x-axis and cross-section perpendicular to y-axis.
So this is formula for this method. This method divided into 2 parts, which is cross-section perpendicular to x-axis and cross-section perpendicular to y-axis. So cross-section perpendicular to x-axis based on x, while cross-section perpendicular to y-axis based on y. So this is formula for Washer method. Washer method also divided into 2 parts, which is cross-section perpendicular to x-axis and cross-section perpendicular to y-axis. And you can see which one is outer layer and inner layer. So, integration can help us solve many types of real-world problems. Also, serve as a tool to solve problems in mathematics and physics involving the area of an arbitrary shape, the length of a curve, and the volume of a solid, among others. We can use integration in certain jobs. Many uses of integration in our life. Thank you.
Cylinder shell method can use in engineering. We can determine the shape of the shell structure with a few different methods. For example, the technique used by Gaudi founded on the principle that a loaded structure in pure tension, when inverted, will be the perfect form for a similarly loaded pure compression structure. The technique was used by Hans and Sutter to design more than 1,000 shells. Therefore, many shell structures have been constructed with the purpose of providing roofing for temple, cathedral, monument, or other buildings. Nevertheless, besides of roofing, shells find application in many other fields. For example, the shell shape is used to cover the fiddler water tank,
we can see figure 6, designed by Teroja. Figure 4, Resort Park in Alatam, designed by To Ito building made of wood. It used cylindrical shell method, also figure 6. Thank you.